Good morning, majors. So today we're going to go over Unit 10, Day 3. This is congruent and similar solids. Also, we're going to change dimensions. So a similar solid is going to be a solid that has the same shape, but one might be smaller and one might be bigger. So they're not going to be the same size. A congruent solid is going to have the same shape and the same size. So it says determine whether each pair of solids is similar, congruent, or neither. So remember, just like we did with similar triangles, we're going to make sure that the ratios are equal. So I'm going to go over here to this pyramid, and it says the height is 8 over the height of the baby pyramid is 4. Is that equal to the front base is 10 over the front base is 5? And is that equal to this side right here is 6 over this side is 3? So if you plug these into your calculator, 8 over 4 is 2, 10 over 5 is 2, and 6 over 3 is also 2. Since they are equal, these pyramids are similar. So they're not congruent because they're not exactly equal. It's not 8 and 8, 10 and 10, 6 and 6. And it's not going to be neither. So it says, so if you wanted a ratio, we would say 8 to 4 is 2 to 1. We would simplify it as 2 to 1, or 2 is the same as 2 over 1. Okay, so this one, they're giving you the diameter is 9, so they're trying to trick you, but this one they're only giving you the radius is 18. We need to compare the same thing. So if the diameter is 9, I need to know the radius. So we're just going to divide 9 divided by 2, and that is 4.5. So I have the radius of this one is 4.5. So it doesn't matter which one I put on top, I just have to stay consistent. I'm going to start with the baby one this time. So I have 4.5 over the radius is 18. Is that equal to the height of the baby one is 10 over the height is 40? So just plug that into your calculator. 4.5 divided by 18 is 0.25, or maybe a fourth. Is that equal to 10 divided by 40? Yes, 0.25. Great. So these are similar also. Let's try one that is not. All right. So this one, they look like they are rotated. This one looks like it's rotated maybe, but it still says the height of this little piece is 2. This height is 2. They tell you that this length is 7. This length is 7. The height of the whole object is 6, and the height of this is 6, and still like the depth is 2 and 2. So they are all equal. So these are going to be congruent figures. They're equal. The measures are equal. This is one that is going to probably be neither, because the radii are the same. So we would put 2 over 2, but the heights are different. So 5 over 10. 2 over 2 is 1. Does that equal 5 over 10, which is 1/2? No. So this would be neither. Okay, guys. So this is something that's really important. We're saying that if we have two similar solids, the scale factor, this is scale factors in the first dimension, maybe they'll say like the ratio of the lengths is A to B, then the ratio of the areas, or surface area is the same thing as area, that'll be A squared to B squared, and then the ratio of the volume is A cubed to B cubed. So we're going to go from first dimension to second to third, and I'm going to show you how to do that. It says 2 different sized balloons are being used to decorate for a party. When fully inflated, the balloons are spheres. The larger has a radius of 18 and the smaller has a radius of 8. Find the scale factor of the balloons. So my radius is in the first dimension. Anytime we talk about length, width, radius, those are going to be the first dimension. Also perimeter. So that is the same dimension as the scale factor. This is the first dimension. So I'm going to say this is 18 to 8. If you guys plug this into your calculator, 18 divided by 8, and then you go to math, enter, it'll make it a fraction. That'll tell you the simplified ratio, which is 9 to 4. Okay. Find the ratio of the surface areas. Remember, area is in second dimension, so what we have to do is we have to square it. It's going to be 9 squared to 4 squared. And you can leave it like that, or you could put 81 to 16. Oops. It's a colon. And then the volume is the third dimension. And that one we're going to cube it. But we have to start with the first dimension and then cube it. So we're going to start with 9 to 4, and then we're going to raise it to the third power. 9 to the third power is 729. And then 4 to the third power is 64. Good. Alrighty, flip your paper over. Let's try a couple. Okay, so this is the 3 dimensions. If we have perimeter or length, this is going to be first dimension. Area is the only thing that's in the second, and then volume is the third dimension. So if we have a square that has the length of the sides is 2 units, the perimeter, to find the perimeter of a square, this is our square, oops, sorry, maybe a square, I can make one actually. And we know a square has equal sides, and they're telling me that all of my sides are 2. The perimeter just means add up the outside. So that would be the same as 2 times 4. So my perimeter is 8. And then the area is going to be length times width, so 2 times 2, which is 4. And then the volume is going to be length times width times height. So if it's a cube, then my width is also going to be 2. So 2 times 2 times 2, which is 8. Okay, we're going to compare that to something that has, our side lengths are going to be 3 units. So this is 3, 3. The perimeter is 4 times 3, which is 12. Our area is 3 times 3, which is 9. And then our volume is 3 times 3 times 3, which is 27. And we're just going to compare them. The scale factor of the side lengths, A to B. So we're going to put the top one on the unit, the one with 2 units on top. So we have 8 over 12, and we can simplify that. 8 divided by 12, plug that in your calculator, and then press math, enter, and that gives us 2/3. If we want B on top, then that will be 3 over 2. The scale factors of the perimeters is still going to be, sorry, this one was 2/3. And then the scale factors is 8 over 12, that's still 2/3. That's still the first dimension. This is still 3 over 2. The scale factor of the areas, what we're going to have to do is plug these in. This is going to be 4 over 9. 4 divided by 9 is, that's all we can't simplify that. But we can flip it, and this is going to be 9 over 4, right? Which is 2 squared to 3 squared. And then the volumes also is going to be 8 over 27. Or 27 over 8. And this is 2 cubed and 3 cubed. Okay, so if the ratio of any two lengths is A to B, then the ratio of the perimeters is also A to B. That's the first dimension. The ratio of the area is A squared to B squared. And then the ratio of the volumes is A cubed to B cubed. Remember that length is one-dimensional, that just has a straight line. We're trying to find the length of something that's a straight line that's in the first dimension, so the exponent is 1. Area is 2-dimensional. We're trying to find the area of something that's 2-dimensional, so the exponent is 2. And if you're trying to find the volume of like a cube, this is 3-dimensional, so the exponent is 3. Remember, a volume has to be something that is our geometric figure that we're learning about, one of our solids. Okay, it says two rectangular prisms are similar with a scale factor of A to B is 1 to 4. Find the surface area and volume of prism B given that the surface area of the prism A is 28 square feet and the volume of prism A is 8 cubic feet. Okay, so my ratio is 1 to 4, and this is the scale factor, so this is the first dimension, is 1 to 4. But we want the ratio for the surface area first. So what we're going to have to do is square each one. 1 squared to 4 squared is equal to, so this is A to B. So A is on top, B is on the bottom. Find the surface area, given that the surface area of prism A is 28, find the surface area of B. We don't know what B is. Okay, so 1 squared is 1, 4 squared is 16, equals 28 over B. Just cross multiply. 28 times 16 is 448. 1 squared is 1 times B is B. So the surface area of B is 448. Okay, and it says find the volume if prism A is 8 cubic feet. So we still have our ratio is the same, 1 to 4, but this time we want volume, which is in the third dimension. So we want 1 cubed to 4 cubed, which is 1 to 4 cubed is 64, equals A's volume is 8. What is B's volume? Cross multiply. 1 times B is B. 64 times 8 is 512. So that's how we're going to set this up. They're not usually asking you for so many things. This one's asking me for 2. So that one was a little bit more difficult. Let's try an easier one. This is my surface area, and this is my volume. Alright, it says a figure has an area of 24 centimeters. If the sides are increased 3 times, what is the new area? So if we're talking about an area, we're going to multiply the length and the width. So length times width equals 24. If the sides are increased 3 times, what is the new area? So we're saying all sides are increased 3 times. So 3 times the length times 3 times the width equals, we're gonna find out what that equals. So we're gonna multiply the coefficients. 3 times 3 is 9 times the length times the width. But we know what the length times the width equals. That equals 24. So I can just plug it in. So 9 times 24 is 216. So my new area is going to be 216. Alright guys, I want you to go ahead and flip your paper over. We're going to look at changing dimensions. We're going to go from one dimension to the other. It says the perimeter is a distance around a polygon. Simply find all of the sides of the polygon and then add, right? In each dimension, the figure is multiplied by the factor of x, the perimeter is multiplied by the factor of x. If you have a rectangle with dimensions of 4 centimeters and 6 centimeters, how does the perimeter change if you triple each side? So this is my original rectangle. This is my original rectangle. And this one, it says, is 4 centimeters and 6 centimeters. You have a rectangle with 4 and 6. How does the perimeter change if you triple each side? So our perimeter is going to be 6 plus 6, which is 12, plus 8, 4 plus 4, which is 8. So my perimeter of this one is 20. I'm just going to add them all up. I have a new rectangle. They said I'm going to triple each side. Oops. Sorry, I'm underlining it. So that means we're just going to multiply everything by 3. So 6 times 3 is 18. 4 times 3 is 12. So 18 plus 18 plus 12 plus 12 is 60. How did that change? What do we multiply it by? 20 times what is 60? Comparing the two perimeters, the perimeter is multiplied by 3. The area change. Area is the space inside of the shape. So we're going to talk about the second dimension. If you have a rectangle with dimensions of 4 and 6, how does the area change if you triple each side? So again, we're going to have these two rectangles, and we're going to find the area this time. So this one is 4, this one is 6. Remember, to find the area, we just multiply them. 6 times 4 is 24. But now we're going to multiply each side by 3 again, which is 18 and 12. And to find the area, we're just going to multiply them. 18 times 12 is 216. So what did we multiply 24 by to get 216? It's going to be 3 squared. We're in the second dimension, so that is 9. And then this is the third dimension, so it's going to be 3 cubed, which is 27. Yeah, so try it out. Show that it's 27. All right, we'll try one example. A company introduced a box that was twice the height of the original box. What is the volume of the new box? So they didn't change everything, they just changed the height. If the original box was 12 inches high, 7 inches wide, and 7 inches long. So we have a cube, right? We have a length and a width and a depth. And it doesn't matter where you put your numbers. It says that we are 12 inches high, 7 inches wide, and 7 inches long. The only thing that's changing in our new box is twice the height. So it was 12 inches high. Now my new box is going to be 24 inches high. And still 7 and 7. What is the volume of the new box? So we're just going to multiply it. To find the volume, we know we're multiplying 24 times 7 times 7, and that is, let me just write it out, 24 times 7 times 7, and that is 1176. All right, guys, I want you to try these out and come to class prepared. I'll see you guys tomorrow.